Hey Mathsters, I'm Saksham and you're watching Mathsters Nation. So guys, first of all, thanks a lot for showing the love and support on my last video, which was on the proof of MPT and its converse. So if you haven't seen it yet, I'll drop the link in the description box below so you can check it out from there. So now let's start with today's topic. As I said in my last video that in this video I'm gonna solve the questions of midpoint theorem and its converse, the questions related to these topics. So let's begin. So the first question, it will be on your screen right now. So you can pause the video and try the question, and you can continue with the video when you are done with it. So guys, let me now solve the question for you. So the question reads that in a right angle triangle ABC, right angled at B, right angled at B, there is a line, namely BD, where D is the midpoint of AC. Now we have to prove that BD is equals to half AC. That means BD is equals to AD or DC. So how we are gonna do it? First thing, we are gonna do a construction. We are gonna draw a line, for example ED, which is parallel to BC. Now see, these two lines are parallel, so this angle and this angle are gonna be corresponding angles. Therefore, angle AED would be equal to 90 degrees, as these are corresponding angles. Now as AB is a straight line, therefore angle DEB is gonna be equals to 180 degrees minus AED angle. Therefore angle DEB is equals to 180 minus 90. That means it is also equals to 90 degrees. Guys, now one more thing. You will notice in this triangle that D is the midpoint of AC, ED is parallel to BC. Therefore, by converse of midpoint theorem, E is gonna be the midpoint of AB. Therefore, AE is gonna be equal to BE. So now we are done all the basic provings which we are gonna need in the final proving of this question, that BD is equals to half AC. So now let's begin with the final part of this question. We have to take a bit help of congruency once again. We'll consider the triangle AED and triangle BED. First thing, ED is gonna be equals to ED, as the both are common. Second thing, AE is equals to BE, as we proved it. Third thing, angle AED is gonna be equals to angle BED. We proved this also earlier, if you remember. So now we can see that by side angle side, triangle AED is congruent to triangle BED by the property SAS, side angle side. And so by the property CP/CTC, that corresponding parts of congruent triangles are equal, BD is gonna be equals to AD. And as AD is equals to half AC, as D is the midpoint of AC, therefore BD is gonna be equals to half AC, hence proved. So guys, now after having solved the first question, let's move on to the second one. The second question would also be on your screen right now. You can again pause the video and try the question, and when you are done with it, you can continue watching the video. So now it's my turn to solve the question for you guys. So what does the question states? The question says that there is a parallelogram, namely ABCD, and there is a diagonal AC, and P is the midpoint of DB, and there is a line PQ which meets CB produced at point R. Now, the question is asking us, and one more thing is given in the question, that CQ is equals to 1 by 4 AC. A very important point of the question. So, the question requires us to solve two things. First thing, that R is gonna be the midpoint of BC, that means BR is gonna be equals to CR. And the second thing, it wants us that we prove that PR is equals to half dB. Let's end this point. So now let's start with the question. First thing, we know that in a parallelogram the diagonals bisect each other. That means DB will bisect diagonal AC. That means AO is equals to OC. Now we can write OC as OQ plus QC. OQ plus QC would give us OC. Now see here, OC is the half of the diagonal AC as DB is bisecting it. Therefore, we can write OC as half AC. And OQ we can't do for anything. Let's just read it in as it is. And QC, it's given in the question that it is equals to 1 by 4 AC. Now, we have to take out the value of OQ. So, how we are going to do that? We'll we'll move 1 by 4 AC this side and change its sign to negative. So OQ will be equals to half AC minus 1 by 4 AC. So on solving it, we'll get that OQ is equals to 1 by 4 AC. That means this is also 1 by 4 AC, this is also 1 by 4 AC. Therefore, Q is the midpoint of OC. Therefore, OQ is equals to QC. So now, after having proved Q being the midpoint of OC, let us consider the triangle DCO. In this triangle, first thing, P is the midpoint of DC. P midpoint DC. Second thing, Q is the midpoint of OC. Therefore, by MPT, midpoint theorem, PQ is gonna be parallel to OD, and second thing, PQ is gonna be equals to half OD. PQ is gonna be parallel to OD, and PQ is gonna be equals to half OD. Right now we require this part, so let us keep this thing right now at the side. Let's see towards it. PQ is parallel to OD, therefore PR is also gonna be parallel to DB. So now let's take the triangle CDB. In this, PR is parallel to DB and P is the midpoint of DC. Therefore, by the converse of midpoint theorem, R is gonna be the midpoint of BC. And so here we have proved the first part of the question. So now let's prove the second part of the question, which asks us to prove that PR is equals to half DB. We'll again take the triangle CDB. In this, P the midpoint of DC, R we proved it in the first part that is the midpoint of BC. Therefore, by midpoint theorem, PR is gonna be parallel to DB, that we have already proved. And the second thing, PR is gonna be equal to half D, B. So here we end with the second and the last question for today. So guys, that was all for today. In my next video, I'm gonna solve some more complex questions of midpoint theorem and its converse. So hit the subscribe button to never miss an update from my channel. Like the video if you haven't done it yet. Comment on the video, share it with your friends, family members, relatives. I'll see you in the next one. Till then, keep learning, keep exploring and keep innovating. Jai Hind.